4.5 Exponential and Logarithmic Equations. We start with the property of logarithms, and it seems pretty inconsequential, but what you want to pay attention to is notice that x and y and of course the base are all supposed to be greater than 0. That's going to come into play when we're talking about our domains, but overall this property is going to help us to solve some of the equations. Example 1, solve each equation, round to the nearest thousandth. In general, when you see this problem like 1a and it says a base 8, we're going to do a log base 8 on both sides. So a log base 8 is going to cancel out an exponential base 8. And so we do a log base 8 of both sides. So log base 8 of 8 to the x, most of that's going to cancel out because they're inverse operations and just give me x equals. Now over on the right side we have to use our change of base formula. So we know log base 8 of 21 is going to be log 21 over log 8. And that becomes a calculator question. So round to the nearest thousandth it says, so x is approximately 1.464. Part B is a little bit harder because you've got a base 5 and a base 8. So there are a couple of different ways to do this. I think the easiest way is just to pick one. I'm going to pick the base 5. I'm going to try to get rid of the base 5, and so I'm going to do a log base 5 on both sides. Log base 5 of 5 to the 2x minus 3 equals log base 5 of 8 to the x plus 1. Notice it's a log base 5 on both sides. I couldn't do a log base 5 on one side and a log base 8 on the other. I had to do the same thing on both sides. So the log base 5 of exponential 5 is going to cancel out and leave me with 2x minus 3. On the other side, we have to do something weird with our properties from one of the previous lessons. So this exponent can come around to the front here. So remember we did a property like that. And so we're going to pull that exponent, x plus 1, around to the front of that logarithm. So x plus 1 times log base 5 of 8. And you might recognize that's going to be a change of base formula. So you can do it now or you can do it later. I think most of you would probably find it easier to do it now. Log 8 over log 5, 1.2920. Since we're rounding to the nearest thousandth, you might want to keep more decimals than just 3 at this point. But I see 2x minus 3 equals x plus 1 times log base 5 of 8 is 1.292. Follow your algebra rules. We're going to distribute here. 2x minus 3 equals 1.292x plus 1.292, and then it just becomes a regular algebra problem. I'm going to subtract 1.292 over to the other side. So 2x minus 1.292x is going to be, let's just subtract that answer from the calculator. That way we don't have to round. 0.708. And at the same time, I'm going to add the 3 over to the other side. And so that's going to equal 4.292, I guess. 4.292 divided by 0.708. We're just doing plain old algebra. Divide both sides by 0.708. .062. X is approximately 6.062. Now you want to be careful. Technically, I probably should have kept more than 3 decimal places. If you're rounding to the nearest thousandth, you should really type in more decimals. So really what I should have done I should have said 4.29202. I could just use the whole thing, 967422. From above, I took that 1.29 number and added the 3, and then divided by the 0.70, 70797, the number that you'd see right there, 97032.578. That way we don't have to round. And so sometimes you could run into a rounding error on this last decimal place, so you got to be careful with the rounding. So I'd probably recommend keeping more than just the 3 decimal places.